So the next transformation that we look at is reflection. So a reflection matrix, if we're reflecting about the x-axis, we call that reflection matrix mx, and it just equals 1, 0, 0, minus 1. So if we take some pre-image or original point xy and we multiply it by a reflection matrix, we'll get the image of that point about the x-axis. So multiplying these two, top row times the column, 1 times x is x and 0 times y is 0. So I've just got x on the top line. Second row by the column, 0 times x is 0, minus 1 times y is minus y. So if I have some original point xy, I just put it in here and I'll find what its image is. Similarly, reflection in the y-axis, we call it my, and that's just minus 1, 0, 0, 1. Multiplying those two matrices, we get minus x and y. So consider the scenario here. We've got some point A, which is at the point minus 3, 4, and we want to know what its coordinates are if we reflect it about the y-axis, and also what it would be if we reflected that point around about the x-axis. So we write our point A in matrix form. So it's the point minus 3, 4. To find point B, it's a reflection about the y-axis. So we use my, which is minus 1, 0, minus 1. Minus 1, 0, 0, 1 times our A. Multiplying this top row by the column, we get minus 1 times minus 3, which is 3, and 0 times 4, which is 0. So we just have 3 there on the top. Then multiplying the second row, 0 and 1 times minus 3 and 4. So we have 0 and 4. And there we have our coordinates for B. For C, it's a reflection of A about the x-axis, so we use mx. Multiply it by our original coordinates. And this time, if you multiply through, you should find that you get the point minus 3, minus 4. So B is 3, 4, and C is minus 3, minus 4. So we can check that on our picture here. That makes sense. 3, 4 for B, and minus 3, minus 4 for C. So straight away do questions 1 and 2 from exercise 7.7. Another example. So this time we're asked to find the image of the equation after this particular parabola y equals x plus 1 squared is reflected in the y-axis. So it's being reflected in the y-axis, so we're going to use my, which is our minus 1, 0, 0, 1 matrix. So the transformations to each of the points in the parabola are going to be the same. So if we write out, similarly as we did when we were doing the translation matrix, we're going to write out the image of each coordinate. So our x dashed y dashed is becoming minus x and y. So the image of x dashed is minus x, and the image of y dashed is just y. So if we rearrange those so that we make x and y the subject, that's the same as saying x is minus x dashed, and y is the same as y dashed. Then we're going to substitute those back into our original equation for the parabola. So we end up with y dashed when we substitute in for this y, and we're going to substitute in minus x dashed for this x. And that's actually just the same as writing what they did down here. All they've done is take out -1 as a common factor and square it so that it goes away. But we should see from our knowledge of equations that if we multiply x by a negative, that just implies a reflection about the y-axis. So you can move on and try questions 3 and 4 from exercise 7.7. Okay, so we need not only reflect around the x-axis and the y-axis, we can also reflect about other lines. So for instance, we can reflect points about the line y equals x, so that's the diagonal through the x, y axis. So we could take this point here, reflect about the line y equals x, and get the point over here. So reflections about the line y equals x, we need this reflection matrix, which is the which is the matrix 0, 1, 1, 0. So if we take some original point, multiply it by our reflection matrix, we'll get our reflected point. So an example from the textbook, we're asked to find the image of the point 3, 1 after it's been reflected about the line y equals x. So we're going to use this particular reflection matrix. We write that in the, write down the matrix transformation. So it's going to be 0, 1, 1, 0 times our original point. Our pre-image point is the point 3, 1. Substitute that in, do the required multiplication here, and we end up with the point 1, 3. So all that happens with this type of reflection is that our x and y coordinates are inverted. So we started with the point 3, 1, and we end up with the point 1, 3, which you can see here. We start with the point xy, and we end up with the point yx. Not only can we reflect around that line, but we can also reflect around lines that are parallel to the x and y axis. So we could reflect around a line x equals 1, start on this side at the point -3, 2, reflect it around that point, and get the point 5, 2. Or we could reflect around a line parallel to the y-axis. So it could start on the top up here with the point 2, 3, reflect it around that line, and get the point 2, -5. So the transformations that are required, so if we're reflecting about a line x equals a, we multiply first by the matrix -1, 0, 0, 1, and then we add this matrix here, which is 2a plus 0. So that comes from working out, in fact, what the distance is between our line and the y-axis and doubling it so that we get where our new point's going to be positioned. If you want to look at the proof for these two, have a look at the textbook. So, and then a reflection about the line y equals b. So that's our b for this particular question, -1. We first multiply it by the matrix 1, 0, 0, -1, and then we add the matrix 0 to b. So an example. So we're asked to find the image of the point 3, 1 after a reflection in the line with the equation x equals 1. So because it's we're going to use this setup because we're reflecting around the line x equals 1. Our a is equal to 1, so 2 times 1 is just 2. and that's the required transformations. So if we substitute in the original point or the pre-image point, substituting in 3, 1, now at that point I'd probably just chuck it into my CAS and work it out. So the way I did that was always do that. Oh, not do that first. That's better. So we've got -1, 0, 0, and 1 multiplied by 3, 1, and we are adding another matrix, and it's the matrix 2, 0. Hit enter, -1, 1. Done. Another way to think about it, I prefer to sometimes think about straight away rather than doing all those bits of calculation. I actually just write this as so in other words, I've evaluated all of that junk in there just to get -x plus 2a over y. Same for reflection about a line y equals b. And if we use that method when we do this question, we can just write this is straight away equal to -x plus 2a over y, substituting our original values in, which are just just 3 and 1. So we have -3 plus 2 times our a, which was 1, oops, over our y, which was 1. And we get -1, 1. So I didn't need to use my CAS if I did it that way. So the textbook actually summarizes the reflections in a really nice table. So it gives you an x-axis reflection. I just write that as x over -y rather than leaving it. I multiply those two out, and similarly if you multiply those two out you just get -xy, and if you multiply these two matrices you just get yx, and those are those two that I just did previously. So try questions 7 and 8, and that's it for that exercise.